Hello and welcome to the solutions to the 2024 Deferred maths paper. So these actually came out fairly recently, along with marking schemes. So the answers to each of the questions are out. However, I wanted to do my typical thing of speedrunning the maths paper and seeing, kind of giving live commentary on what I think of the questions. So if there's any mistakes, they will obviously be rectified in a pinned comment down below the video, possibly an hour or so after the video releases. So, as I said, this maths paper has only been released, and I'm just going to give it an hour and just see how it goes. So, obviously, the exam number for all these, I'll just put as 1, 2, 3, 4, 5, 6. Yeah, we know that. So, Casio, the old Casio FX83 GT, my calculator of choice. So, I'll just take it out. Sort of in prep. Now, I haven't seen these questions before, so I'm doing this completely blind. So the current time is 3 minutes past 1. I aim to finish this by 3 minutes past 2. So, let's get into it. Factorize fully that. Okay, so there's factors of 5 in both of them, so it'll just be x squared take 9, which is just 5 times, that's just a difference of squares. Okay, that's good. Factorize fully that. Okay, we can take out, what can we take out from the front? We can take an x out and we can also take a 2. So if we take a 2x out from these, we'll get 3y take 4. And can we get a 3y take 4 here? But if we write this as 21y take 28, we can write this as, both of them have factors of 7 times 3 and 7 times 4. So it's 7 times 3y take 4. Okay. So that's plus 7 times 3y take 4. Just rerunning the 21y take 28 like that. So it's equal to 2x plus 7 times 3y take 4. Just confirm we'll get 6xy. We'll get minus 28 as well. We get plus 21y and take 8x. So that's correct. Solve these simultaneous equations for x and y, which are real. Okie doke. So x squared plus 4xy is minus 168, and 4x take 2y equals 7. Alright. So let's think about how we can do this. We can actually replace this 4x with something in terms of y. So I'll make that note. So I'll rewrite the equations. X squared plus 4xy is negative 168, and 2 is 4x plus 2y takes, or equals negative 7. So we can write here that 4x is the same as negative 7 take 2y. So if we put that into equation 1, we'll get x squared plus y times minus 7 take 2y equals minus 168. Oh, we still need something for the x squared. Okay, so we'll scrap that approach. I thought it was a bit of a approach, but we're just kind of doing it the normal way. What would we like to replace? Again, I'll just try to replace the y in this case. So I'll make y the subject here. So 2y is negative 7 take 4x. So y is just minus 7 over 2 take 2x. And then that's going to go into equation 1. So I'll get x squared plus 4x times minus 7 over 2 take 2x. That's equal to minus 168. So what we'll get is we'll get an x squared plus 4 counts with a 2 to make 2. So that's actually minus 14x. Then we'll get 4 times 2 is with us minus 8x squared. That's equal to minus 168. So I'll just do that. Make sure that's correct. Get 4x over divided by 2. That becomes minus 42x. 4 times 2 is 28 over 2 makes the 14, where the negative sign comes out, and then we'll have 4 times 2 is 8, and that comes out. Awesome. So we'll get, how we do this? I'll bring it over to the right hand side. So we'll get a 7x squared popping out. We'll get a plus 14x, take 168 equals 0. Each of these you can divide through by 7. As far as I'm aware, I think 168 is divisible by 7, but let me just check. It is, it's 24. So from here, I think this can be factorized as x plus 6, x take 4. 6x minus 4 gets the 2, and that gets 24. So x is 4, or x is negative 6. So then to complete the pairings, y is just minus 7 over 2, take 2 lots of that. So for the first one, minus 7 over 2, take 4. We'll take 2 lots of 4 is minus 23 over 2. And this one, negative 6, let's do it, so plus 12, so 17 over 2, I believe. So minus 7 over 2 plus 12. So 12 takes 7 over 2. I'll just double check when I'm here. 17 over 2, and then here is minus 7 over 2. Take 2 lots of 4, which is 8, gets minus 23 over 2. Okay, perfect. Question 1 done. First 2 terms of arithmetic sequence are 3 and 10. Find the sum of the first 100 terms. So A is 3, and the common difference is 7, and the number of terms we're looking for is 100. So S100 is 100 over 2 times twice the first term plus 99 differences. So that's 50 times 6 plus 99 times 7 is 34950. Okay. First, fourth, and nth terms of this sequence are the first 3 terms of a geometric sequence. Find the value of n. Oh, okay, this is fun. So the first term is 3. T4 will, if you remember, Tn is a plus n minus 1d. So it's 3 plus 3 differences. So that's 2 7 is 21, so it's 24. So if it's a geometric sequence then of 3 terms, then T3 over T2 is the same as T2 over T1. So T3 is this term. So actually, if we find we'll find the common ratio first. Actually, whoops. Why is this not rubbing it? Why is this not rubbing it? Hello? Hello? Why is this not rubbing it? But actually, what I have noticed is that because that's 24, the only way that that could be a geometric sequence is if we're timesing it by 8. So actually, the common ratio is 8. Because it'll go 3, then to 24, that's timesing by 8, and then times 24 by 8 is 192. So we're effectively solving 192 is the first term plus n minus 1 differences. So 192 take 3, and then we're dividing that by 7. So actually, let me just do this. So 192 take 3 is a 189, and that's 7 times n take by 1. Divide that by 7, we get 27. So n is the 28th term. Perfect. What time are we at now? No, too bad. Okay, use induction to prove the sum of the first n natural numbers is that. Okay, so we'll start with the base case. So let n equal 1. So 1 is just 1 times 1 plus 1 over 2. 2 over 2 is 1. So therefore true for n equals 1. Now we're going to say let n equals some number k, for k also being a natural number. So we'll just say assume that 1 plus 2 plus 3 plus da 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 up to where a k is k plus 1 over 2. Alright, so now we'll prove that that's true for n equal to k plus 1. So what we can say from that is 1 plus 2 plus 3 plus da 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 up to k plus the quantity k plus 1. We're seeing if that's the same as k plus 1 times that will turn into a k plus 2 over 2. From the induction hypothesis, we know that this entire section, we're guessing that's a k plus 1 over 2. So we'll see that if k times k plus 1 over 2 plus this alternative 2, k plus 1 over 2 is k plus 1, k plus 2 over 2. Well, this is all common denominator and we can combine these. So that's equal to just k plus 2 lots of k plus 1, because we have 2 k plus 1s and then another k, so that's k plus 2 amounts of k plus 1. And that's the same just because we know that multiplication is commutative. So if true for n equals 1, and by assuming true for n equals k for k in the naturals, proves true for n equals k plus 1 again in the naturals, that implies the statement is true for all n that are naturals. Okay. First few questions done. F and g are two functions defined as follows. Find g of f. Okay, so all the x's are being replaced with f of x. And it wants it in expanded form. Okay. So g of f of x is equivalent to g of 6x take 5. So g of f of x is 6x take 5 squared take 2, 6x take 5 plus 1. Expanding this, we get that's a 36x squared. 5 6 are 30 takes, that's 60x plus 25. Take 12x plus 10 plus 1. So grouping everything together, we get a 36x squared. 60 and a 12 gives minus 72x. And then 25, 35, 36. Okay, they're all integers, so that's totally okay. A bit of an odd question here, right? 81 in the form 3 to the power of r, where r is an integer. Okay. Well, we know 81 is 9 squared, which is 3 squared, so that's 3 to the 4. So 1 over 3 to the 4 you can write as 3 to the minus 4, so r is negative 4. Following expression in x, where x is greater than 0 and real. Right, expression in the form p log base 10 of kx, where p and k are real. Oh, this is interesting one. So we're going to use the change of base formula. So we can write that log of the base 100 of a quantity is log base, our new base of this, but dividing by log base 10. So log of the base we want, and the input is preserved, but just divided by the scaling factor. So log base 10 of 100 is just 2. So it's 1/2 log base 10 of x. So what we'll have is that log base 100 of x turns into this, so 1/2 log base 10 of x. Log base 100 of 18 will turn into log base 10 of 18 over, so that's another half. And then log base 100 of 3, again, this turns into 1/2 log base 10 of 3. So therefore, summing them together is just 1/2 log base 10 of x plus log base 10 of 18 plus log base 10 of 3. Now, log a plus log b is log of the product. Oh, that's a minus sign. Haha. Thankfully I spot that. So I think what I'll do first is I'll just do this in sort of the inner brackets first. That'll give us 18 over 3 is 6. And then times that together with 6x. So that's equal to 1/2 log base 10 of 6x. So it wants it in real, so that's fine. So p is 1/2 and k is 6. Okay. Right, the following complex number in a plus bi, where a and b are real. Okay, that should be okay. So we get 2 times 3 is 6, minus 8i, plus 15i, and then that's technically minus 20, but the sign flips again, so plus 20. Take 20i and we'll have the signs flipping here, but then they'll flip again because of the I times I. So we'll get technically plus 2, but then take some minus 2. So that equals the real part, so 6 is a real part. That's also real, and that's real. So 26 take 2 is 24. And then we'll have, what would be here? So 15 take 28 is just minus 13, I think. See, when I'm sitting here, it's a lot difficult. So 15 take 8 take 20 is, yep, so minus 13 times I. Hopefully I haven't made any silly arithmetic errors yet. I really hope not. 4 complex numbers are represented by the dots. They satisfy that. Use your information to write wx, y, and z next to the correct complex number. Ooh, okay. So, my instinct is saying that this here is z. So it's next to the dot. So that's z. But because if we essentially duplicate that, we'll get up to here, which we know is y. So y is twice the length of z. Similarly, this reflection, this negative z, effectively rotates at 180 degrees around. So that looks about 180 degrees, or in fact pi radians. So this one down here is x, and then by process of elimination that's w, because these are at right angles to each other. Okay, so nice question. Used a Moivre's theorem to find the two solutions to that equation. Okay, let's find our radius first. If you've dealt with this a lot, this should be common that radius is just 2. And if we physically plot this, we're going to get 1 but minus 3. So it's going to be somewhere down here. So this is the angle that we want, but I'm going to take this angle as kind of a reference. So we'll note that theta plus phi is 2 pi. So that's 1 and that's root 3. So tan of phi is opposite over adjacent, so square root of 3. So that means that phi in this case, I think it's pi on 3. Yeah. So that implies that the angle we're actually looking for is 2 pi minus that. So it's 5 pi on 3. So therefore we can write z as r, we'll write z squared because this is the value of z squared. So z squared is r times cos of 5 pi over 3 plus 2 pi n, and then plus I sine of 5 pi on 3 plus 2 pi n. So z is just root 2 times, this all gets halved, so this is cos 5 pi on 6 plus pi n plus I sine of 5 pi on 6 plus pi n. So for n equal to 0, we'll get z0 is root 2 cos of 5 pi on 6 plus I sine of 5 pi on 6. So this will be square root of 2 times minus root 3 on 2 plus I times 1/2. So this will combine with that, and we'll get minus root 6 over 2 plus root 2 over 2i. And I forget that n equal to 1 to check for the other solution. Still a root 2 at the front, but now we're just, that's actually 11 pi on 6 plus I sine of 11 pi on 6. So cos of 11 pi on 6 is positive root 3 on 2. So it's root 2 positive root 3 on 2 plus I times sine of 11, yeah, sine of 11 pi on 6 is, gets minus a half. Which will this be root 6 over 2 take away root 2 over 2 times I. So those are the two solutions, if I've done that correctly. It's been a while since I've done a de Moivre same question like that, so apologies if I made a very simple slip. Okay, f of x is that, the derivative is that. Use the point minus 1/8 on the graph to find, the point 1/8, minus 1/8 is on f of x. Use the inverse to find f of x. So we'll just be using a fundamental theorem of calculus here to show that oh, what's going on here? So that f of x is just the integral of f dash of x with respect to x. So this is then equal to the integral of just 6x plus 4 dx, which will be add 1 to the power divided by the new power, so 3x squared plus 4x, and then plus some constant. But we know that when x is minus 1, f of minus 1 is 8. So 8 is 3 by 1 squared plus 4 by 1 plus c. So that's 8 is c plus 7, so c is just 1. So f of x is 3x squared plus 4x plus 1. Alright. Y equals that. Find the value of y when x... Oh, seriously? This is just 2 log of 8. Yeah, I'm reading that right. 2 times log of 2 cubed is 8, and it wants it to 4 decimal places. So y is 2 natural log of 2 cubed, which is 2 log of 8, which is 4 decimal places is 4.1589. Find dy by dx. Okay, I knew there's something coming up. So we're going to have to use a chain rule here, because I mean, we could sort of bring this power down if we want to, but my log laws are evading me for some reason. So I think we'll just do it with this log cubed in it. So the first function is u, so u is x, so u prime is 1, and v is the log of x cubed, which if we work this out by the chain rule, if u is x cubed, u prime is 3x squared, y is log u, so y prime is 1 over u. So we'll get just 3x squared all over x cubed, which just becomes 3 divided by x. So yeah, 3 times whatever x is log x. So v prime is just 3 divided by x. So dy by dx is the first times the derivative of the second, so that vanishes and becomes... What is going on with this? Why is it jumping all over the place? So I'll be very cautious of this. So the first times the derivative of the second plus the second times the derivative of the first, so log of x cubed. And I think I will have to bring this out because we'll get 3 plus 3 log of x. So again, what's that? So a is 3 and b is 3. First times the derivative of the second plus second by the derivative of the first. And we get that. Okay. Seems pretty straightforward. I mean, this is just kind of a one-liner. H dash of x is just 2 cos of 2x. Sine goes to cos, but by chain rule that 2 has to come out. So 2 cos of 2x. Use integration to find the average of h from 0 to pi over 6. So 1 over pi on 6 take away 0 times the integral between those two boundaries in the other order of sine of 2x dx. Sine goes to minus cos when integrating, but the factor divides. So it's effectively 1 divided by pi on 6 times the value between 0 and pi on 6 minus a half cos of 2x. So that turns into 6 divided by pi times, so the first one minus a half cos of, that'll go to pi on 3, is minus a quarter take, and then it'll just go to 0, which is 1, so that's take away negative a half. So it's 6 on pi times a half minus a quarter is just what am I doing? So it's minus, I can't believe I'm doing this. Take away negative a half. Yeah, it's just a quarter. Which is 6 over 4 pi, so 3 divided by 2 pi. Okay. Functions defined for between 0 and 5. Graphs made 3 straight line segments, 2 which horizontally. Use the graph. Tensor parts bi and b to y. For what range of values, if any, is f dash of x negative? So if this is f of x, then f dash of x is going to be negative between these two bits, because that's when the function itself is decreasing. The tangent line is itself negative. So it'll be on the interval of, well, for x it's going to be between just 1 and 2. So x is an element of 1 and 2, but then square brackets. Okay, a is a constant with a between 0 and 5, right in the range of values of a, if any, for which this expression is positive, the integral of that. Okay, well, clearly if it gets to here, it's positive. It gets to 1. If it gets to 2, I'm assuming that because of the straight line that these two triangles that I've shaded are of equal area. So between a is 0 and a is 2, so if a is sort of less than or equal to 2, but less than 0. So actually I'll be careful about this because some people consider 0 to be positive, but I'll just won't consider it this time. So between 0 and 2. Okay, so that was the first section done in about 20 minutes, so not too bad. Let's get to this one. Makes different types of sheds. They can model the profit as that particular function. Okay. So I'll go straight to a table and fill these in. So 400x, take 5x squared, take 0.4x to the third, take 900. So it's between 0 and 25 in steps of 5. So, we actually got minus 900, 95, that's that. 2200, 2625, 1900, yep. And minus 275. So, from table. So draw the graph on the axis below. So 0 goes to 900, so it's about there. 925 is about there. 2200 is, well, that's 2250, so 2200 is like slightly below that. 2625, well, that's 2500, so 2625 is there. 1900 is about there. And then minus 275, it's kind of tanking back here. So the graph, at least for this domain, it's going to look a bit like that. The profit from shed type G can be modeled as that horrible expression, so that x equals negative 16 as a root. So g of minus 16 is just minus 2 times negative 16 cubed plus 55 negative 16 squared plus 974 negative 16 takes 66880. But because of this show that, I'm just going to presume that that's true, so this equals 0, so therefore true. That's kind of one thing you can really guarantee, is that if you sort of copy down this by just using sort of the definition of a root, then you're grand. Find the other two values of x. Okay, well, if x equals negative 16 as a root, that means x plus 16 times. Now we want a 2x cubed, so, or a minus 2x cubed, so the only way we can do that is with a minus 2x squared plus bx plus, and the only way we can get a minus 6688 is, again, it's going to be 16 times what gives us 6688, so we'll consider 16 times c is minus 6688, so c is minus 418. So that will just turn into a minus 418. So all we really need to do now is just find that value of b for this to be equal to that expression. So let's actually look at the x squareds and how many ways we can get an x squared. So we can get an x squared from the 16 times this term squared, so we can get a minus 32x squared. But we can also get an x squared from the two x's multiplying, so that's plus bx squared, and we want that to equal the 55x squared. So b take 32 is 55, so that implies that b is 5787. So we'll get that this thing is equal to x plus 16 times minus 2x squared plus 87x, take away 418. Now the roots of this, I'll quickly find those. So minus 2 is I'm going quicker at these quadratic formulas. So we get x is 38, or x is 11 over 2. So that's the other two roots, 38 and 11 over 2. Perfect. Should type H can be modeled as that. Right. Okay, that's not too bad. So we can kind of start by just looking at the roots. So one of the roots is 21, so it'll be a times x plus 21, x take 12, x take 47. I'll just actually quickly save this while I'm here. Okay. So now we just need another value. So that's actually our x equal to 0. So when x is 0, h of 0 is minus 1,316. It's equal to a times 21 times 12 times 47. But those negatives are going to cancel. 0 times 21 times 12 times 47. We get 11844. So that implies that a is minus 1316 over 11844. Which is minus a ninth. Which is real, so it's within that boundary. So h of x is minus 1 over 9, x plus 21, x take 12, x take 47. Okay. Oh, another financial question that is very junior cert-esque. Okay, let's have a read of this. Whether it's gross annual income of X euros or X is real, 20% on the first 40,000 and 40% on the balance. So it's kind of the rest of it. Annual tax credit of that. Take the tax credit into account, Martha pays 1/6 of her gross annual income in tax. Oh, okay. So this is really just kind of a generalized thing. So if we kind of start with, oh Jesus, what keeps happening here? So on the first 40,000, she's taxed at 20. But we can't necessarily infer that she makes more than that. So, well, if it's not the other rate, then it's not possible. So we can consider the first 40,000. So it's 40,000 times 20%. 8,000, and then the rest is extra. So the rest is just the x take away that initial 40,000 times 40%, which will just be 0.4x, and then 40,000 times 44 gives minus 16,000. So that's the total amount that she has to pay is 0.4x take 8,000. But then that's annual tax credit 3550, so we're just gonna that's the total tax she has to pay, so we're gonna take out a further 3550. And we know that 0.4x take 11,550 equals 1/6 of her gross annual income, so x divided by 6. So swinging this over and swinging that over, we get 7x over 30 is 11550. So 11550 times 30, 7 hopefully gives us something nice, and it does. X is 49,500. And I'm pretty confident that that's correct because it's a nice number. It wouldn't be like 48157.42 or something great like that. So I'm happy enough with that answer. That's that question done. Okay. Company produces firewood. Oh, fun. Company cuts the wood and then leaves it in a warehouse to dry out. The water content, W of T, is percentage of firewood that is actually water. The following occasion. Describe the water content while it's drying out as a percentage of the firewood. Okay. T is a mix. Okay. So we're going to water content of the wood at the start of the drying process and after 8 weeks. Give your answer as a percentage. So t equals 0 here and t equals 8 here. So t equals 0, this goes to 1, so we'll get 5 plus 20, so that's 25%. And in this one will just be w of 8 is 5 plus 20 e to the minus 0.079 times 8. So again, we'll just type that into a calculator, minus 0.079 times 8. Nearest percentage were appropriate. So that's, oh, what's going on? I hate when this keeps happening. So it's 16% to the nearest percent. Cells the wood once the water content is 10% or less, work at the least number of days, then it must try out. Okay, so W of t is just 10. So 10 is 5 plus 20 e to the minus 0.079 times t. So that becomes 10 minus 5 is 5, divided by 20 is a quarter. 0.079t. So I'll take natural log of both sides and then divide by that. So t is natural log of a quarter or 0.079 the negative. So we'll get natural log of a quarter over 0 or negative 0.079. Okay, least number of days. Okay, so 17.548 weeks. So 17.548 times 7 is the rough number of days, so it's roughly like 122.8 days. So on day 123, the water content will be below 10%, because at day 122 it's actually not fully below. So if you want full days, it's going to be 123. I thought my power cut out there for a second, but sometimes Acrobat does that, so it's going to be a bit slow for the next couple of minutes. So where the value of w prime of 5, where w prime of t is the derivative, give your answers the percentage per week. So I'll write that w of t is 5 plus 20 e to the minus 0.079 t. And it wants the derivative. So w prime of t is that constant disappears. If it's differentiating, this comes down as a multiplying, so minus 0.079 times e to the minus 0.079t. I'll just fully expand this. 20 times minus 0.079. So it'll be minus 1.58 e to the minus 0.079t. So w prime of 5 is minus 1.58 e to the minus 0.079 times 5, which as a unit of percentage per week is, well, we're expecting it to be negative because e to the something power is always positive. So the t is minus 1.06% per week. Awesome. W prime of t is always negative, yep. And the mod of w prime of t gets smaller as t gets bigger. Explain what this means in the context of the water content in the wood. So this always negative just implies that we show that it's like the actual values are decreasing. So I'll just label these kind of as points 1 and 2. So at point 1, the amount is decreasing. So rate of change will also be negative. Then the second bit of information is that the magnitude of it gets smaller. So what that means is that this percentage per week will keep getting smaller, sort of the longer you leave it out. So the magnitude of the rate decreases the longer the wood is dried, which I think should be a sufficient enough definition. Oh, there's more to this question. Okay. Company starts using new warehouse. The wood dries faster. That is, the water content decreases quickly. U of t is really just the same, but instead of minus 0.079, it's that. Write down one possible value of k so that U of t describes the wood drying out faster than W of t. Okay, well, in fact, we really want this to be decreasing quicker than a minus 0.079. So if we just pick a value of k that's more negative, so k is -1, that's a particular value that... oh, have I screwed it up? Oh, it dries out faster. Okay, so that, yeah, the drying rate therefore is quicker, so we need a more negative constant. Oh, I put it in the wrong box. Oops. So it should go there. What was this? The diagram below shows the graph y is w of t for a given domain. On the same domain, sketch a possible graph of u of t. The one thing you're going to have to ensure is that it still kind of asymptotes to the same... it asymptotes to the same point. That's what I was missing. So it decreases, yes, quicker, but it will still have an asymptote at 5. So that right there should be an asymptote. Okay, in 3 consecutive years, the amount of firewood the company produced relative to the previous year increased by 6, 8, and 17%, respectively. The total increase over time is equivalent to an increase of R% each year compounded annually, where R is a constant. Ooh, this is a fun one. In 3 consecutive years, the amount of fire produced by the company, or the amount of firewood the company produces relative to the previous year, so 6%, so we'll say it was 100, then it goes to 106. Well, actually, technically, as a percentage, if this is sort of compounded, we'll get for the first one, its final value is 1 plus 0.06. So that's F1. So that's that one, so 1.06. Then if it's 8% of that, then it'll, so for the second one, so the F2 is 1.06 times 1.08. Which is 1.1448. And then F3 is 1.1448 times 1.17. So I'll do 4 decimals, 1.3394. So 1.3394 plus 1.1448, 6. That's equal to a relative increase of 3.5442. But of course, there's all those extra ones coming out of it. But it's for the fact that it's increasing. So if we just sort of truncate the 3, it's the equivalent of a 54% increase over 3 years. 54.42, so 54.42 over 3. That's to 1 decimal place. It is an 18.1% increase per year, linearly. Oh, it's compounded. Oh, hang on. What am I thinking? Why am I doing this linearly? So, there's me misreading the question again. So that's relative compounding is that. So if we want that, we want f is p times 1 plus whatever that is to the power of 3, but we want that equal to this relative thing, so 3.5442. So r is just the cube root of 3.5442 minus 1. Which is a much higher increase, but I don't think it's right. It's like 52.5%. I'm not confident on this question, in fairness. So I think I'm just going to leave it there. And we'll just move on. Because that's kind of the motivation you should have in exams. If this is a question you're really struggling with, especially the M parts, just move on. Okay, so a water break, and we're back. So f and g are defined as below. We used to make an image of wave for logo of the region is there. Therefore, the g cuts the x-axis when x is 1.5. So g of x equals minus 6x squared plus 25x. Say 24. So when x is 1.5, we should expect that the y value is 0. So minus 6 times 1.5 squared plus 25 times 1.5 take 24 is 0. So therefore cuts x-axis, since x equals 1.5 is a root of g. Awesome. Use calculus from the local minimum of f. So what was f? Minus x cubed over 4 plus x squared. I think it was. Yeah. So f dash is power comes to the front, takes 1 off the power, so it becomes minus 3 times the quantity x squared on 4. So again, I'm just factoring the minus sign out, plus 2x. So that's equal to 2x, take 3x squared over 4. I want that to be 0. So does this have, yeah, okay, so crosses when x is 0, so that's kind of the trivial solution. So I'll get 3x over 4 equals 2, so x is 8/3. If we look at the graph, graph of f is there, 8/3 is 2 and a bit, so it'll probably be over here, but because we're talking about a cubic, especially a negative cubic, that's the local maximum. So in fact the local minimum is this point here. So I think what I'll mention is that it'll be x equals 8/3, but actually x equals 0 is the local minimum. Because up here, if you were to do the second derivative test, and you'd get, what would you get here? You get 2, take away 6 over 4, so 3 over 2. Yeah, it'll be negative, which implies it's a maximum. So in fact, subbing this 0 in here will get you that local minimum. So I think it'll mention this 8/3, but in fact the minimum occurs at 0, the local minimum. Use the calculus from the x coordinate, the steepest part of the graph of f of x. So that is when f prime is a maximum. It's only between 0 and 2. Okay. So we want to maximize this, but that actually occurs at the point of inflection because it's going steep, but then it's not steep anymore. So actually, this steepest part of the graph just occurs at the point of inflection, which we can work out by taking the second derivative, which, as I said, will be 2 take away 3 over 2x. 0. So 3 over 2x equals 2. So x equals 4/3. And it just wants the x coordinate, so that's fine. So now it's finding the area of the shaded region. So the first thing we have to consider is actually just the point where they intersect. Now, do they intersect at 2? Because it looks like they do, but I just want to be sure. So it'll be minus 8 over 4 plus 2 squared. That's 2 for f, so that's checked. Minus 6 by 4 plus 25 by 2, take 24. That's 2. Okay, so they're fine. They do actually intersect x equal 2. So it'll be the area is the integral between 0 and 2. Now, because they have the same limits, we can work with this fine. It's just f take away g dx. So it's the integral of 0 and 2. Now we'll have minus a quarter. Excuse, this is only cubic. F take away g, so that's plus 7x squared. Take 25x plus 24. Let's just send this in. Add 1 to the power divided by the new power is minus 1 over 16x to the 4. Plus add 1 to the power divided by the new power, so 7x cubed over 3. Take 25 over 2x squared plus 24x. Now the 0 will just cancel everything. So all we really need to work with is that 2. So minus 1 over 16 answer to the 4 plus 7/3 answer cubed. Take 25 over 2 answer squared plus 24 answer. 47/3. Doesn't give us units, so I'll just write units squared. Yeah, I'm pretty happy with that. Oh, okay. A company makes candles in a oh, what's a cone doing here? Cone is paper too. All geometry is paper too. What's a cone doing here? Okay, companies comes to the right circle of the cone, each comes to both the waxes in the shape of cone, so its height h is the same as the diameter. So h is just 2 times the radius. So v is 1/3 pi r squared h. So 1/3 pi r squared times 2r. R cubed, so that's 2/3 pi r cubed. Okay. In the cone of melted wax increase the rate of 0.5 cubic centimeters per second for the rate of the radius. Okay, related rates of change. So we want to find the radius. That's increased in respect to time. So we want dr by dt. But that's the same as dr times some dt. The only one missing is dv. Okay. dv by dt we know is 0.5 cubic centimeters per second. And that's fine because we have a radius in centimeters. Now, we know v is 2/3 pi r cubed. So dv dr is 3 comes to the front, multiplies these two, 2 pi r squared. So that's, I'll just write dv by dr. So dr by dv is 1 over 2 pi r squared. So we get the dr dt is 0.5 we can read that as a half. So we get 1 over 4 pi r squared, handy enough. And when r is 4, dr by dt is 1 over 64 pi units of centimeters per second. Cool. Alright, question 10. We're finally here. Oh god, what the hell is this? Brought in simple harmonic motion? What is this? Wow, okay. A weight is placed on a table with walls at each end. The 2 points A and B marked to the table where the distance A to B is 120 centimeters. Okay. It travels 120 A to B. From B it travels back to A, but 4/5 at a point C. And then 4/5 of the way to B back to a point D. Okay. It's able to in centimeters okay. So stage 1 is that first instance, so that's 120. So then it travels 4/5 of the way, so it travels again 4/5 of the way. if that's a whole number as a fraction, okay, 384 over 5. Because it's effectively just shrinking off 1/5. So there's a fifth gone. There's a fifth gone. Okay. And then we'll just times that again by 4/5. So 1,536 over 25. I mean, I've no like belief in that, but as an ever. Stage P is the first stage where the distance traveled by the way is less than 10. So this is a geometric series with A being 120 and R being 4/5. So Tn is AR to the n minus 1. So it's 120 times 4/5 to the n minus 1. And we want that to be less than 10. So we'll set it equal to 10 first. So 1 over 12 is 4/5 to the n minus 1. So we'll have n is 1 plus log base 4/5 of a 12th, which is very odd, but log base this both sides adding 1. So 1 plus log base 4/5 of a 12th is about 12.1359. So P is the first stage. It would be stage 13. Because at stage 12, it's not yet at that 10 centimeter thing. Work at the total distance the way it travels to first n stages, give you answer centimeters. Okay, this is just sum of a geometric series. So because the rate is less than 1, it'll be 1 take away r to the power of n over 1 take away r. But of course we know r, it's 4/5, but we also know a, that's 120. So it's 120 times 1 take 4/5 to the n, all over 1/5, but we can just rewrite that up as 600, 1 take 4/5 to the power of n. So cool. Work out the distances AC and AD. Okay. Well, A to B consists of the distances A to C plus B to C. Now B to C we know is that one in stage 2. So stage 2, I think it was 96. Yeah, so 96. But we know AB is 120, so 120 is AC plus 96. So leaves AC is 24 centimeters. Then the distance of B to C we know is 96. So let me just make that clear. What we're looking for AD. You can think of AD as consisting of BC, but then taking out, so BC is that distance, but we want A to, what's A to D? Well, if it's still 4/5 away from there, it's the exact same. So so B to D is also 24. So let me rework this. So we know that BD is also 24. So A to D is A to C we know is that. So if we can work out A to D being A to C plus C to D. We know C to D is actually stage 3. Okay, perfect. So A to C is 24 plus C to D, which is stage 3. So 384 over 5. Which I'll write as a decimal is 100.8 centimeters. So it gives it here AC 24 and then 100.8. Both in units of centimeters. Okay. If the weight were to continue moving indefinitely without stopping, it would tend towards the point x between a and b. Work out the distance at x from sum to infinity of a geometric series in your solution. Okay. I wasn't thinking using the sum because it would just be a bunch of TRs. TR is essentially just, or have I got this mixed up? So it's the distance the weight travels. So if each one of these stages is 4/5 shorter than the rest, then my guess would be that it lands somewhere in the middle because of that constant 4/5 ratio. So, I mean, I can work this out using a bit of logic in that distance a to x should realistically be 60. I know it doesn't make much physical sense because obviously they might have two different spring constants. But if it's continually traveling 4/5, it should settle somewhere in the middle. If each of them gets chopped off one by one. That's my intuition. If I'm wrong, obviously I'll notate it in the pinned comment. Now, okay, final question. Jesus Christ. What is pumped through? Containing two types. For each pipe, the water is pumped at constant rates. Pipe A can fill in 18, pipe B in 15 continues empty. Water is then pumped indicating through two pipes. After 5 minutes, A becomes blocked, so the water no longer comes through A. Water continues until it's full. Find the total length of time it takes to fill the container. Okay. And find the first find a fraction of the tank that each pipe fills in 1 minute. So in 1 minute, A fills 1/18 and B doesn't fill 1/15. Oh, it does. It fills 1/15. What am I thinking? This one takes longer. So in 5 minutes, A plus B will just be 5/18 plus 5/9. So that's 5/6 in the first 5 minutes. So B must fill 1/6 of the tank or the container, whatever it is. But if B fills 1/15 per minute, then how many is it going to take to fill a 6? So x times 15 is 1/6, so 6x is 15. So x is 15/6, which is 5/2 more minutes. So total is the 5 minutes plus 5/2, which is 7 minutes 30 seconds. And that's the paper done. So slightly over an hour. I mean, normally I get these done in an hour. You do have 2.5 hours for them, but I am going to stop there because it's quite a long video, and in fairness, I definitely screwed up in a couple of them. So as I said, I'll leave advice in the pinned comment just for any mistakes. So thanks for watching. If there are any mistakes, do let me know, but otherwise I'll rectify them all in the comments.